Okay, this is Utah Middle School Math Project 4.3a. This is part 2. This video is only going to go over just this last little bit that we ran out of time to finish in our last video. As a quick review, here's what we're doing. We're going to be setting up 2 proportions for each problem. How do we set up 2? All we're really doing is writing 1 and then rewriting it as the reciprocal. We're flipping it, rewriting it as the reciprocal. The one thing we want to make sure of is to write the units of our comparisons. When I say write the units, I'm talking about this. Body and jumping. What is it that we're measuring? Okay, that's what we're talking about with the units. You do not need to answer the questions. So again, our focus is not on answering the question that is being asked. Our focus is on writing these 2 proportions. Later on, we're going to come back and we're going to solve these, but we're not solving them right now. Here's an example that we did in our last video as a quick review. A 5-inch frog can leap 50 inches in one jump. If jumping distance is proportional to body length, how far should a 60-inch human be able to jump? Notice it said if, it doesn't say it is. We're just saying if that were proportional, how far would a 60-inch human be able to jump? Look at how we've set this up. I've got my body, so that's the body length, and I'm comparing body length to jumping distance. Okay, set up your units first. What are we comparing? Understand that. And then it says a 5-inch frog. So here is a 5-inch frog. That 5-inch frog can leap 50 inches. So the jumping distance of that frog is 50. Notice all of this information right here deals with the frog. Okay, let's keep on reading. If jumping distance is proportional to body length, how far should a 60-inch human be able to jump? That's the height or the body length of the human. And it's asking the question, how far would that human jump? That means we don't know. And anytime we don't know, that's when we're going to use a variable. J for jumping distance is appropriate. Notice all of this was representing the frog. All of this here is representing the human. So this is still organized in a very reasonable way. All of the frog's information is together. All of the human's information is together. We can have all of the body information on the top, all of the jumping information on the bottom. So it makes perfect sense. That's 1. What do we do now? To write the second one, we just find the reciprocal. We just flip-flop it. So body 560, that was all on the bottom or top. Now body 5 and 60 is all going to be on the bottom. Jumping distance was all on the bottom, but all of the information on the bottom has now been flip-flopped. So jumping 50 and J is now on the top. Notice I still have all of my information here about the frog, all stacked. So I have a frog ratio. And all of the information about the human is still stacked, so I still have a human ratio. Could you solve this? Yes, that's not the point. We're not solving today. All we're doing is writing these proportions. So please understand that. If you tell me what the variable is, if instead of a variable, if you have a number, that means you haven't followed those directions. So that video was asking you to complete the rest of these. Let's complete those together now so that we can make sure that we understand what's happening. I'll do just one more on the video. Pause it. So if you haven't done your part and already done them, then you can get started on those. Eli won 2 out of 3 chess games in one day. At this rate, if he played 33 games, how many did he win? Again, focus less on answering this question. Focus more on writing our 2 proportion equations. Eli won 2 out of 3 games one day. So what I'm going to write is how many games he won over how many total games he played. So he won 2, he played 3. Here's my 1. Here's the played in a different color. Now, this is not an equation yet. We need to know what is it equal to. The question's asking if he played 33 games. So if he played 33 games total, that would be the number of games played is 33. And again, folks, I know it's killing you. You know what goes up here because of our previous unit. You know how to work these equivalent ratios. Again, that's not the point. So how many games did he win? Do we know? No, we don't know. So we're using a variable. I like W to represent games won. Could you solve this? Yes. Are you going to? Not yet. Instead of focusing on solving it, we are now going to write our second one, which is nice and easy. We've done all the brain power over here. Now we just got to flip it. So now instead of games won over games played, now it's going to be games played over games won. So it was 2 over 3. Now it's going to be 3 over 2. It was W over 33. Now it's going to be 33 over W. And again, I'm going to keep my highlighting consistent. 1, 2, W, 1, 2, W, all highlighted yellow. And games played is 3 and then 33. Games played is 3 and 33 highlighted green on the top. All right, that's another problem done for you. Will you please pause? Make sure that you have all of these done before you continue on in the recording. Ready, set, go. All right, number 4, all together now. Eli won first place in a spelling contest. Millie won second place. They had to share a cash prize in the ratio 8-5. It doesn't specify, but I would be willing to bet that since Eli won, he's getting the greater part of that ratio, right? And Millie, who took second, is going to get the lesser part. So I'm going to put Eli compared to Millie in the ratio that I'm assuming Eli is the 8 and Millie is the 5. That is going to be equal to Eli receiving $72, Millie receiving an unknown amount. We're going to call that M. You can call it X, you can call it anything that you want. From here, though, I know I just need to flip that, and then it's going to be Millie compared to Eli in the ratio 5-8. If I'm flipping Millie and Eli, I need to flip all the associated parts. So instead of 8-5, it's now 5-8. And instead of 72 over M, it's now M over 72. So Eli all the way there, flipped all the way along the bottom. Millie all along the bottom, flipped. Now Millie is all along the top. How'd you guys do? Yeah? Next one, Bargain Betty sells sneakers and scooters in the ratio 3-8. So again, I'm going to assume that the sneakers, even though it doesn't say, I'm going to say that the sneakers are the 3 because it's listing that first, and the scooters are the 8 since it's listing that second. So setting this up with my units first, sneakers, to scooters in the ratio 3-8. Continue reading. The store sold 21 sneakers yesterday, so that 21 is going to go up here with the sneakers. How many scooters did they sell? That's the question. We're not sure. How many scooters? I'm going to go with T for scoot. There's my first proportion. Flipping it to its reciprocal to find the second one. And I end up with scooters, which is 8, and T. Two sneakers, which is 3-21. The next one, got just enough time to go over probably one more. In 1.5 hours, a sprint race sled dog can run 30 miles. So in 1.5 hours, that sled dog can run 30 miles. How long would it take? That's a question that's being asked. How long would it take for the dog to run 12 miles? Oh, I did that backwards. How long is the time question? We don't know how much time, but the dog is going to go 12 miles. So it looks like I'm going to have hours compared to time. Since I color code, I'm going to work ahead. Yes, Luke. Sure do. Thank you. Hours compared to miles. Good catch. Thank you for that. Yep, hours is time. So hours is 1.5 to 30 miles, not time, 30 miles. Comparing that to an unknown amount of time, let's call that h, and 12 miles. So when I flip that ratio, now I'm going to have miles, 30, and 12, to hours, 1.5, and h. Okay, and the next one. An ant can crawl 3/4 of a yard in half of a minute. How long will it take for it to crawl 12 yards? So again, yards I did in red, so yards I'm going to do in red. The time was half of a minute. The time is the question that we're asking, and that's the part that I don't know, so I'm going to do that in blue. So as I'm setting this up, I'm not going to make the same mistake as last time. We have yards that we are comparing to minutes. So setting up my proportion, those are my units. I'm going to have a ratio equal to a ratio, that's what a proportion is. And looks like it's 3/4 of a yard. And 12 yards. Down here we've got our 12 yards. And those 3/4 of a yard happened in half of a minute. So the question is, how long will it take? We can call that m for minutes. Now we need to reverse that to its reciprocal. We're going to flip it. Where instead of yards over minutes, now it's minutes over yards. And what was half a minute on the bottom is now half a minute on the top. And what was 3/4 on the bottom, or excuse me, 3/4 on the top is now that 3/4 on the bottom. We're asking what about when it's 12 yards and how many minutes will that take? Again, we'll get to solving all of these in a future lesson. Right now, we're just focused on writing. And here's the last one. Students who worked ahead and did this one on your own, you might find that you wrote your proportion a little bit different, and that's okay. There are multiple ways that we can write it, and I'll show you what I'm talking about. So I'm comparing the small to the big. It says the side lengths are proportional. So that means side 3 is going to be proportional to side x. So I can set it up that way, where we're comparing the small sides of the triangle to the larger side of the triangle. This 7 is going to be proportional to that 10.5. So I'm comparing the small side to the large side with the ratio of 3/7. That's the small side and the large side here in the smaller triangle. And that is going to be equal, because it's proportional to the smaller side and the bigger side. So of course, I can always reverse that, turn it to its reciprocal, where I am going to have the large side, which was 7 and 10.5. Since I color code, I sometimes work a little bit ahead like that. A ratio equal to a ratio. And the small side is 3 and x. There's my 2. There is another way that we could have done this, and one other way that we could have done this is I could have taken these and set them up as their own ratio. So you might have decided to do a small triangle to a large triangle, And what that is going to look like is small triangle has the side lengths of 3 and 7, while the large triangle has the side lengths of x and 10.5. Notice what is different here. Interestingly enough, these are all equivalent and they will all solve and give us the exact same result. But here I had the small sides written in red. Here I have the small sides stacked. Here I had the large sides in green, and here I have the large sides stacked. So that's another interesting way that you could have done it. If you started your proportion like that, please know that that is okay. There's nothing wrong with that. That's it for this lesson. Your homework is the 4.3a homework section. Thanks for watching. We'll see you next time.